Today we're going to talk about a new case study called OpenSSL Heartbleed. Okay, so this case study was adapted from the OpenSSL Heartbleed security bug that actually happens in 2014. Okay, so you can get more information if you want from heartbleed.com. So OpenSSL Heartbleed bugs, I'm not sure how many of you heard of this, but for security people, for IT people, everyone should have heard of this. Okay, this OpenSSL Heartbleed bug, it's one of the most devastating security events in the history of the internet. Okay, this is not exaggeration, that's the fact. Okay, it's just because everybody is using OpenSSL, whether you realize or not. Okay, but this security vulnerability is such a big issue, such a devastating issue. Okay, the good news is that happens in 2014, and people already fixed the problem. And another good news is this is mostly running in the back end. So for common people like you, like ordinary users, they probably never notice what's happening. Okay, but that's really a chaos in the IT fields and in the security fields. So at the time of disclosure in 2014, about 17% of the world secure website were to be vulnerable to this bug. Now, at first glance, maybe 17% is not a big number, but remember this, those are supposed to be secure server, okay? Which means those servers, including like Gmail, Yahoo Mail, okay, like your banks, like a lot of online e-business websites, okay, that's causing a lot of issue because they are supposed to be secure and trustworthy. Okay, this bug is extremely easy to be exploited by the hacker and extremely difficult or almost impossible to be detected by the IDS, intrusion detection system. Okay, now of course once everybody know about the bugs, they fix it, then they fix the problem. But before you fix the bug, that bug is just kind of just like a backdoor, open door for everyone. Okay. What another significant issue is, if this is a software bug, it's relatively easy to fix. You just upgrade your OpenSSL package. But a lot of hardware, like a lot of routers or e-commerce equipment, they are also using OpenSSL, and that causing significant issues because those are hardwares. Now, a little bit of background. Let me pull back a little bit, introducing what is OpenSSL. Okay, now, so everybody go to Amazon.com. Okay, you already notice on Amazon.com there's a HTTPS protocol. That's where you visit things. Okay, so let me bring up the websites here. Okay, so when you visit Amazon.com, okay, you see the small log here. Okay, well, I think we kind of mentioned this before. This basically means HTTPS, and for any website using the HTTPS, okay, most likely they are using OpenSSL. Okay, not 100% of them are using OpenSSL. OpenSSL is just one way to achieve HTTPS. Okay, but it's one of the most popular way. Okay, and also most trustworthy way to achieve HTTPS, and that's why this is so devastating. Okay, the blue line here are the market share of Apache Web Server, and you can see Apache Web Server kind of pretty stable, just take like 50 to 60% of the market share. Okay, and the red line here are Microsoft IS server, and there are some other servers like Sun, Nginx, or Google, or many other different servers. But you can see Apache consistently take about 50% of the market share. Now, most Apache web server, when you are trying to set up HTTPS, okay, majority of them are using OpenSSL. Okay, it's just because it's trustworthy, it's built in, it's commonly used, everybody's using it. Okay, so as you can see, that causing huge issue. Okay, now for some extremely larger organization like Google, they probably using their own version of web server and their own OpenSSL software, SSL software, so they might be okay. But for majority of other companies, okay, for a large number of e-commerce companies, okay, they are just a victim of OpenSSL Heartbleed. Now we'll continue to talk about, introduce more on this technical issue. I hope when you watch the video it make better sense, but if you still have a hard time to catch up, that's okay, we'll explain later. Okay, so these are the screenshots people did to verify what websites are vulnerable. Again, that happens just a few, I think it's 1 day or 2 days after the data breach. Let me go back to here. It's on the 7th. Remember here, it's on April the 7th. That's when it make to be the public. And the scan was done on April the 8th, 1 day after the data breach. And you see the list. Testing Yahoo. I'm not sure if font is too small. Testing Yahoo vulnerable 1 day after. Stock Overflow vulnerable. Flickr vulnerable. Sogo vulnerable. The list can go on and on and on. I'm not going to go through this list again. Okay, so you can see that opened a huge vulnerabilities. That's something called a zero-day attack. Means on the 7th, the vulnerability is known to the public, but on the 8th, okay, people haven't patched their system. And actually, I personally also do the similar test. Even after 3 days, okay, on the 10th, there are still many websites haven't patched their system. Okay, that's zero-day attack. Okay, now here is another list of Heartbleed top 1,000 websites which are vulnerable. Now, of course, today they already fixed it, but it's just after a few days, a couple of days, those companies are still not fixed. Okay, so I'm not sure if you can see some familiar name here, but there's tons and tons of companies. Okay, top 10,000 list. Okay, so let's go back to the bug itself. Who found the problem? Who found the bugs? So the first public evidence of the bug appeared as OpenSSL advisory on April the 7th. Okay, the bug was discovered and reported by 2 different sources. One is some guy from Google Security. Okay, the other is a Finnish security company. Okay, called Dominico something. Okay, now who exactly report these things to be the first? We don't know. It might be both company discovered independently, or might be somebody get some hints from the other guy, and we don't know, and we don't really care. That's a different issue. But the bug is known to be the public on April the 7th. Okay, that's a huge issue. let me give you some background. Talk a little bit about the Heartbleed extension, Heartbleed protocol. So, first of all, we already know why people are using SSL. That's just help you to do the HTTPS secure communication on the internet, like all the e-commerce, all the websites, banking websites, e-commerce sites, they are using HTTPS, and they are using SSL, and mostly using OpenSSL. Okay, there's a very specific function in OpenSSL called Heartbleed. Heartbleed is basically, let's see here, the SSL Heartbleed extension provide a way to test and keep alive secure communication. Okay, that's the main idea of Heartbleed. It just keep the secure communication alive, so you don't have to renegotiate the communication every time. That's just a way to improve the communication, improve the speed, okay, performance, which is quite often quite normal. Okay, now the vulnerable code, okay, which causing the problem, was developed by Dr. Steven Hansen. Okay, and I believe I did a little bit of Google search on this gentleman. I think he's from Germany or Northern Europe or somewhere, Denmark, in that area. Okay, I believe Dr. Hansen is innocent. Okay, remember, this is an open source project. Basically, that means when you contribute to this open source project, you don't get paid. Okay, people are using their spare time trying to contribute to this open source project. Okay, so the same thing happens for Dr. Hansen. He just used his spare time to contribute and write the code, and the code are so beautifully written, it's widely adopted and used by almost everyone. Okay, until these big bugs. Okay, so I think I believe Dr. Hansen is innocent in this case here. Okay, it's just a careless mistake. Okay, the unfortunate things about this event is that you are only vulnerable if you are doing the right thing and keep your version up to date. What this means is, if you are using older version of OpenSSL, which is older than 1.0.1, you are safe, because the older version, okay, doesn't have this vulnerability. And the newer version, which is 1.0.1, which is the current version at that time, also the most popular version, that one has the vulnerable code in it. So the things here is a slightly vulnerable. If you keep updating everything, boom, you are the victim. Okay. So this is basically the Heartbleed protocol. Okay. Just as I said, when you try to visit Amazon.com, you kind of just stay there for maybe 10-20 minutes before making your final decision, and all your communication are being secured, being SSH. Okay, so in order to make the customer have a better experience, you want to keep the secure communication between you and Amazon to be keep alive during your entire browsing session. And the browser keeps sending the Heartbleed to Amazon saying, okay, keep the connection open. I'm still surfing online. So the web server will keep things open. So that's basically why people are using Heartbleed protocol. Now, the only problem, okay, the older version of the Heartbleed protocol, it doesn't track whether the older version of OpenSSL does not track the length. Okay, they just send back whatever you did, okay, and whatever happened to have in the memory. Okay, so that could causing problem, because they just randomly when when the people hack into your the Heartbleed vulnerability, okay, it will send back whatever things inside the server's memory. Okay, because it's random, but it could include the password, account information, or even worse, which include the private key. Okay, so that's causing the problem. Let's just look at the technical detail, exactly what happens. Okay, so the bug in the OpenSSL, okay, it's really boiled to this line of code: buffer equal OpenSSL dot memory allocation, mallocate. Okay, that's basically means memory allocation. If you are familiar with C code, this is a very commonly used C function. So part 1 plus part 2 plus payload plus some padding. Okay, this is a pseudocode, not the real code, just showing what's happening. So the server will just allocating some memory. Okay, the only problem is there's no length track on the payload. Okay, which means it could, if the hacker starts sending you something overloaded things, it could causing buffer overflow, which you can fix this by adding the length track. So if 1 plus 2 plus payload plus 16, which is just what we talk about here. Let me change the fonts a little bit. So this thing's here, it's just what this thing's here. Okay, you should track if this is bigger than a predefined value you want to, then do it. But if you didn't do this track, you kind of over allocate things. Okay, and that could causing problem. That is something called a buffer overflow. Okay, overflow. And so the hacker, what the hacker did is the hacker could control the size of the package sent to you, and send to you an oversized package. And when you reply back, you also reply an oversized package, which exceed the normal things. And those replied package could have some sensitive data. And this vulnerability are so easy to be explored. You can actually download the code from this URL. Okay, and there's a lot of other attacking code targeted at FTP, SMTP, and emails. And there's also websites which tell you you can test the vulnerability. So let's bring up the websites here. So this is the websites which you could use to test whether your website is still vulnerable. So I just use MTU as example. Boom, something went wrong. It doesn't mean it looks like you are safe, that's just not sure. Okay, so that's the websites. And here is the other websites which actually shows you the code which you could use to explore this vulnerability. And this is a plain Python code. Again, for those people who know Python, you could take a look. And the interesting thing here is the actual package they want to send. And you can see this is an oversized package. They just put some random number here, make it to be an oversized package. Once you send this oversized package to the web server, and causing problem. Okay, the rest is just sending and receiving data, nothing really special. Okay, so that's just the code already there. And here is just a screenshot of the code, which just we kind of talked about already. Okay, so what should you do with the Heartbleed? On the server side, you need to disable the Heartbleed right away. And the real fix is to upgrade your OpenSSL. Okay, when it comes to hardware, you probably need to stop the hardware and start buying the new hardware. Okay, before you get a new hardware, stop using the old hardware, which could use OpenSSL. For the users, you can change your password, you can test the site yourself. Okay, you probably should do nothing until they fix the problem. That's very important. If they didn't fix the problem and you just go ahead and change your password, that's actually causing more issue. Okay, so basically, the people saying you don't want to visit SSL websites like email, bank, or Facebook for a few days. Okay, at that time, but now it's okay to visit them. Okay, so a few take back things. The number one thing people are thinking is, it's open source really secure. Okay, the common theory behind this is like this: open source software, it's more secure because the community can inspect the software and identify bugs much easier. Okay, the keyword things here, it can but not view. Okay, because remember, even though there's a lot of people trying to look at the different bugs, but they are doing this for nobody paid them to do this. Okay, complete on voluntary basis. So you really rely heavily on people's self-motivation. Okay, and there's another myth behind this. It's because most people think, okay, it's pretty safe, it's already checked by other people, so I don't need to check it again. Like for me, I never check those open source software. Okay, I don't have time to read the code. I just assume it's okay. But this open SSL Heartbleed will tell us, no, that's not a safe assumption. Okay, so the OpenSSL project have 21 contributors and 25 branches and 57 megabyte of source code. Okay, it's a lot of code, and there are 21 contributors. Basically means someone like Dr. Hansen. Those are well-respected people who are contribute to the project. Okay, it is not a huge project. It's actually a small, tiny project if you compare with others, but it's big enough, and the bug is obscure enough, so it went unnoticed for about 2 years. That's really something annoying. Okay, the code has been there for 2 years and went unnoticed for about 2 years. There are many conspiracy theory behind it. Some people say maybe the NSA already knows about the bug, but they didn't want to notify the public because they could use this as a backdoor. I don't know. There are many different theories, and some people just claim Dr. Hansen is a spy of a foreign intelligence agency, whatever. But we don't talk about conspiracy theory here, but those are just some thoughts on the open source software. Okay, another thing we want to talk about is something called ZeroDay Vulnerability. Okay, we kind of already talked about ZeroDay Vulnerability many times. This OpenSSL really is a good example. So as you can see, the vulnerability become known to the public on the 7th. Okay, on the 7th, people start knowing there's a problem. Okay, but until 8th, most company haven't fixed it. Until 9th, most companies start fixing it. And even until 10th, 3 days after the news, there are still many companies haven't fixed it, particularly for a lot of international websites. Okay, as you can see, this leaves a huge window for hacker to utilize this. Remember, once this vulnerability is made known to the public, there's already code. People can easily write the code to start utilizing this, and those codes are available. And hacker could use this window of 3 days to hack you. That's a typical example of zero-day attack.